Welcome to Engineering Numerical Methods. This is Module 2, Systems of Linear Algebraic Equations. So here, we're going to talk about the following methods. First, we would like to review the previous lesson, which is Introduction to Python. So if you haven't understand Python, so it would be better if you visit Module 1. But here you can see that we're using a Jupyter Notebook again, and here we have codes as well as the lesson. Okay, so we will have introduction, then we will discuss Gauss elimination method, LU decomposition method with symmetric and bonded coefficient matrices. We also have pivoting, matrix inversion, iterative or indirect methods such as Gauss-Seidel and conjugate gradient method. Okay, so that would be our outline for this module. So the learning objective for this module is first that we will be able to carry out numerical analysis of simultaneous equations, which is A times X is equal to B, where A and B are matrices of their own. Okay, it can be 2 by 2, 3 by 3, or n by n, whatever the value of your n. And then we would like to execute and troubleshoot a Python program. Lastly, we would like to solve simultaneous equations using Python. So although we will know the different methods, it would be better if we use Python because this is one of the famous and widely used programming language in the scientific community. Okay, first we'd like to review. So before using the Python notebook, so we would like to use this inline and then import. And if you haven't installed some of the if you are not updated or if you want to upgrade your system, you can also use this code pip install. So this will install whatever things you need to install. So you can run that one. You can press shift enter. So after running pylab inline, so you can see an interactive namespace. So it means that whatever the code, this is the code cell, and this one here is a markdown cell, which is this one. Okay, basically there are two, and then the rest are simply code. Markdown, another variant of markdown. Okay, so you can see here the different requirement installed just in case there are many updates for the Jupyter notebook or for the Python that was installed in this computer. Okay, so that's it. And then we've learned so far about matrix to scalar element-wise multiplication. So if we have matrix A, the random, so this one is a code generator between 0 and 5 with a size of 4 by 4. Okay, so we have that one, so it's a random digits. Okay, and then multiply by 2. Actually, if you run again, so you will have a different set of matrix, 4 by 4 matrix. Okay, and then we have matrix to matrix or matrix multiplication. So if we have to multiply 2 times the matrix by its own, so we have this one. Okay, so you can also use print if you would like to see the matrix itself without the array, but depends on you. But if you would like to do some mathematical maybe solutions or mathematical operations, okay, you might as well do that. No? So you don't use print if you want to multiply or do other operation, mathematical operation. And then this one is quite important later, which is finding the eigenvalue of a matrix. We need to import a library called linear. Actually, this is linear algorithm or algebra. Okay, linear algebra library, no, from SciPy. Okay, SciPy library with a function or list of libraries for linear algebra, and then eig, or this is a function eig. Okay, so if you want to find the eigenvalue of matrix A, you just simply run that one. Okay, so this is the eigenvalue. If you notice, there are some imaginary number. Okay, so I suppose you've learned this one in your advanced engineering mathematics. What is an eigenvalue? And it was also introduced in the previous module.